Hey everybody, so in this video we're going to be solving a Cauchy-Euler differential equation. I'm sorry if I pronounced that wrong. So um, here's our problem that we want to solve, and the equations you need in this case for a second order differential equation are these two. So what we're doing basically is converting from differentiating with respect to x into differentiating with respect to t. So we're going from the x to the t domain. So we're just going to go ahead and do these substitutions inside. So I'm going to need a little space. So what the problem is, let's move right here. Okay, so x squared times the y prime. Now what is the y prime? Okay, the y prime right here. So basically I'm going to rewrite these, but keeping because this is messy to write all these fractions, just keeping track that it's in the t domain. So then we have our differential equation, x squared times y double prime becomes, so that's 1 over x squared. 1 over x squared times y double prime, keeping track that it's in the t domain, okay, t domain. All right, and that minus y prime. And then minus 3 times x, and then that cancels out with the 1 over x. Then multiplying by derivative, differentiating now with respect to time. So dy by dt. I'm just going to write it, no, I don't want it to be that messy. So it's y prime. And then, so you can just cancel these out, x squared, and x squared. And then, all right, I forgot, it's homogeneous, so equals 0. And then the final differential equation now that after it's been converted into the t domain is going to be looking like y double prime minus y prime minus 3 times y prime equals 0. So we could combine like terms right here, and then we're left with y double prime minus 4y prime equals 0. All right, and also going to keep note that it's in the time domain. And then at the end we're gonna have to convert back into x, with respect to x. So this is basically we could use the auxiliary equation of this. It's linear homogeneous second order with constant coefficients. Okay, so it's homogeneous. We don't have to worry about finding the yp. Remember, the general template of the solution is equal to yp plus y sub c. So y sub c is the solution when it is in differential equation, when it is in homogeneous form, and you use the yp in the case that it's not homogeneous. So when it's homogeneous, like in this case, we don't have to worry about the yp, and we just worry about the y sub c. So the y sub c in this case, we're gonna solve for it using the auxiliary equation of this, and this becomes, all right, let me remove that t. So this right here becomes m squared, you could use any other variable, m squared minus 4m equals 0. And then we're going to have to solve for m, so what we could do easily is just factor out the m, and then we're left with m minus 4 equals 0, right? Because it's second order right here, it's second order. That means we need two solutions, two linearly independent solutions. So the m, okay, m equals 0, our solutions, and we have m equal 4, right? So then our y sub c, which is our y, the general solution, is equal to, so we have c1, first constant, times, okay, e to the 0 x. So e to the 0 x, which is just 1. So that's 1. Okay, and then plus c2 times e to the 4x. Oh no, oops. E to the 4t, because we're in the time domain. I said e to the 0x here, but it's 0, e to the 0t. Okay, and then, so that is our formula. That's our general solution. And then, I forgot to mention this earlier, but the conversions that you're going to, when you want to convert back into the x domain, we have to keep note that x is equal e to the t, and then t is equal to ln x. Okay, So wherever you see an e to the t, replace it with x. Wherever you see t, replace it with ln x, and so forth. So this then becomes, so y of x, our general solution, is equal to c1, okay, nothing changes there, times, okay, c2 e to the 4t. T is ln x, so e to the 4 ln x. But we know we could bring this guy, the 4, up, so that would be, okay, ln x to the 4th, and then these cancel out, and then you're finally left with y to the x is equal to c1, c1 plus c2 x to the 4th. And that's your final solution. That's it.